Hi everyone, very good morning CTech family. My name is Prabal Pandey. I'm from Team 5 Data Modules from DVD batch and CTech Kharghar Institute. So today I'm going to present you a very interesting topic that is Internet of Things, and I have divided this technical topic into three parts. First, where I'll be showing you some electronic components and explaining you bit about it, not in detail, just a little bit information. And then I'll move to the PPT and show you some theory about Internet of Things and show you a small clip on multiple examples based on Internet of Things. And then at last I'll show you a few demo projects uh, on Internet of Things by using Arduino and Volt IoT platform, cloud, and that's it. So here I begin my first part, and the very basic component of any electronic gadget is resistor. So I'll start with resistor, and I'm sure each and every electronics engineers are familiar with resistor. And here I present you a component which is called resistor, and you can see that there are multiple colors, and you can count this color 1, 2, 3, 4, 5. So in future, if you can come across this type of resistor, you can easily calculate the resistance of this resistor. So I'll just show you how we do it. So you just hold it like this. Now you will be confused from which side to hold. So there is a simple trick. So you just hold resistor and see if you can close. If you see closely, you'll see there is a golden strip on the second right uh, from my left hand. It's very shaking. I'll try to show you. Is it visible now? If not, let it be. So hold it like this. Start counting from your right. Always there will be a golden or silver color on the in either of the sides. So which side is having golden color or silver color? Hold it, point it that to the left side. So after holding it like this, you can see the color. The first color is red. Second color is even I am unable to see properly, purple, and third color is black. So these three color symbolizes. So again, these three color is divided into two part. First color represent the first digit. Second color represent the second digit of the resistance, and unit of resistance is in ohm. So and third digit, third color when converted into digit, it gets to the power of 10. So here, the first color is red. So code of red is now again to remember the code of color. I have one technique which is called BB Roy of Great Britain has a very good wife. So I take the initials of the all the letters and then I convert that into a digit. So B stands for black. Then again next B stand for brown. Then third is red. R Roy. So R that third digit is 0, 1, 2. So third that red means 2. Then again next color is violet. So we can count violet. B Roy R Roy of Great Britain has very V comes at number 6, which means 5, because this color coding starts from 0. So 5. So red is 2 and purple, this violet is 5. Now the third color is black. So black comes at number 2, which means 1. So that goes into power, 10 to power 1. So the final that value of this resistor is 2, 5, 25, 10 to the power 1, 250, 250 ohm. Now that this last two color, what does it means? It is the what we call is that we can say error margins 5%, 10%. So second last color, that means the unit value, like gold and silver. If it is gold, gold is little bit costlier, so we will remember it by 5%, like 5%, 5 is for gold. And if it is silver, then 10. And then again, last one is for number that goes to the power of 10. That is brown, which is second number. So that first component, and don't worry, I'm not going to explain all the component like this. So this is only for the resistor, because you will see this resistor in each and every component. I don't think there is any electronic components or any electronic device which doesn't contain resistor. So what is the final value of this resistor? 250 ohm plus minus. Since here, I think it's silver color, not gold. So silver stands for 10. 10% of like error margin. It can be 10% less or 10% more. So that is resistor. Now moving to the second component, I'll show you diode. This is diode. And you can see we have a gray strip here. And this gray strip means that this left side of this gray strip is anode part, and right side is of cathode part, because this lets current flow in only one direction. Current can't flow from both the direction in diode. If you do so, if you place it wrong in the circuit, then this will get damaged. So that's it. Now moving to the uh, third component, sorry, third component. This is this, and I have one more. Where is it? Yeah. So this and this, these are light dependent resistor, or also we call it photo thermistor also. So these are light dependent resistor. What does it mean? Like as the intensity of light increases, resistance value of this sensor or component gets decreases. So as simple as that, nothing more. Now moving to another component. Here I have capacitor. As we all know, capacitor stores electrical energy, and in our fan there are capacitors. And it is advisable that whenever your fan gets damaged, don't touch the capacitor by your naked hand. You might get a shock. So that's it. And capacitors also have different types. This is electrolytic capacitor. This is ceramic capacitor. Now again, moving to the next part, we have the most important thing. We have wires in, like, for doing small projects. We have different kinds of wires. So I'll just show three jumper wires, and these are called jumper wire because we use it with breadboard. Don't get confused with breadboard. I'll explain a breadboard also. So here I'm showing you three different kind of jumper wires. As you can see, this wire has a pin on both the sides. So this is called male to male wire, male to male jumper wire. Okay. Now again, this one is not having any pin. We can insert male part into this. So sorry. Okay. Yeah. So we can insert this male part into this to connect or extend wire. So that's why this wire jumper wire is called female to female. Okay. We also have third type of jumper wire, which is called male to female or female to male, we can call it. Because here we have one side pin and another side we don't have pin. So in case of like we connect one male, we can easily connect one male part to this, and then we can connect this to a breadboard or another device. Okay, so since I'm talking about breadboard, I'll show you how breadboard looks and what how we operate on it. Okay, so I'll just take a pen. I have three different kinds of breadboard. Okay, I'll just explain this one first. So here you can see so many holes in here. Don't get confused. It's very simple. This two vertical line, as you can see here, it is showing plus symbol, and this side it's showing blue and negative symbol. But it doesn't mean that the plus the side which is near to that red line will always be positive or hold live wire. It depends on us on which side we plug in. But what does this line indicates is that whatever you plug in this side, or in between anywhere on the vertical line, so that line will contain the voltage. Like if you have connected, for example, I have connected here black wire, okay, and I have connected white wire here. So you can see that the line on which wire is connected, that will contain the voltage, and the line which is connected with white wire will contain 5 volt or 3.3 volt. Depends on the connection we made through this Arduino and all. So, and yeah, in this part, horizontal line contains the same voltage. So just in simple terms, the voltage in the vertical line is same, and here voltage in horizontal line is same. And these two parts are divided. Means these two are not connected, these two are not connected, and these two are also not connected. So it's simple. Now moving to the next part, I'll show you very important uh, device, or we can say very important gadget for any and every electrical or electronics engineer, and that is multimeter. So I will show you multimeter and explain you about that in just a second. So I was explaining you about breadboard. So here is another breadboard, which is little bigger than that one, but the concept is same. And one more I have just for a small project, and I'll just show you here the I'll show you the working of this in the last section. This is also the breadboard. Here I have connected a, this is LM35. This is temperature sensor, and 35 is odd number, and naming convention are very different in electronic components, so I'm not going to get into that. So just for basic information, this is temperature sensor, and I'll show you one project, and also the data. I have been operating this from since 4 a.m. So all the data has been gathered on the cloud. I'll show you that in later part. But for now, and this is board IoT device which is enabled with Wi-Fi connected with my phone, and I have board IoT app in my phone, and this device and my phone is connected. Along with that, this device is connected with the board cloud, where the temperature reading is has been that reading of temperatures is uploaded over there, and I'll show you that part also. But for now, that's it. I'll move to another components. Now, this this is relay. Mm, Relay is electrical switch. We can say, yeah, it's electrical switch. We have multiple contacts inside the switch. It consists of set of input terminals for single or multiple control signals. Like by giving one input, we can control multiple output devices. That's it. And then here, this is 7 segment display. You might have seen on railway stations or airport. You can see it clearly. Yeah, this is why this is called 7 segment, because uh, this there are 7 LEDs, we can say, or seven. Yeah, you can count it here. Just a minute, I'll show you. I've lost my pen. So you can see that that there are only 7 these LEDs which form all the numbers. If it has to be 0, all the outside numbers will blink. If it has to be 1, only this side, left sides, only 2 LED will blink. Means they will be turned on. And if it will be two, then only upper part, and this side middle one. And so means in sequence you can understand what I'm trying to say, that uh, which number we want, like from 1 0 to 9, we can all print it by using only seven displays. And there is one more display dot which is here, it's not visible here, now you can see. So including all these eight uh, displays, we can form any number. And the combination of this is used in all the places you might have seen on airport, railway station. So I have two of these. So, and the it works. We write a code for this. We have to turn on and off for each and every number, and sequentially it works according to that. Okay, now next component is this uh, ultrasonic sensor. So we measure distance. Also, we can use this for uh, like, for example, calculate for detecting any presence also. So ultrasonic sensors are used in navy or in ships to measure the depth also. Radar, that is called radar, I guess, or lidar. So I'm not clear about it, but this produces a sonar wave, so that when some objects come in between the wave, it gets reflected. So there are two part. One sends that wave and another receives it. So that's it. Now moving ahead, uh, I'll show you. This is a keyboard I had for my project. And here we have 3, 3, 6, 9, 12, 12 inputs. And whatever we press, we have here data cables. It gets connected by using, I have shown you the jumper wires. Through jumper wires, data gets transferred to the board. I'll show you the board also. Okay. Next is this LCD display. We can display two line of messages in this display. I could have shown you the project by using this, but that would take much time. So that's why I'm limiting it over here. Okay, so now you might have heard about RFID, RFID everywhere. This is the RFID card reader. So whenever I have had the card also, but that is with my friend. Okay, so this how this operates is that whenever that RFID card, that detail of that card is all we place, we code the detail of the card in this, and here you can see it has a microprocessor. So the information which holds in the card, and that card is with sometimes it is in the car vehicle, or it is with someone in someone's ID card. So whenever that card comes nearby, it detects. So it just work like that only. I think it as simple as it means, it's just whenever that RFID card whose data is already been saved in this database, then only it will allow. If the details of that card is not saved, then it will not allow. It will not even detect that RFID card. So that's it. Now moving to the next component, I have here ESP8266. ESP8266 is used for connecting local devices or Arduino or our project to the cloud or internet. So here um, there are so many things in here, but I'm again not going detail. So that's it. ESP8266 connects us to the internet. And again, I'm explaining all those components because above all, we always say that we should know the basics of things if we are going to get or know the bigger picture. So that's why I'm explaining, because above all, in each and every electronics and in IoT also, these are the building blocks. Okay, so this is buzzer. I'll just show you the experiment. Later word, I'll show you the experiment with this also. I'll just connect the wire, and I'll get the power supply, it will start buzzing. So, and yes, this is DC motor. You all might be familiar with this. You might have made a science project in school days. So very simple, but you are not familiar with this motor. I'm sure you are not familiar with this motor because this is servo motor, stepper motor. It rotates in at an angle. Like while coding, we give that at what particular angle this will move. And as you can see that in robotics, most of the time this motor has is used because it has to rotate the leg or hand. It has to move. It has to do it in at an angle. Okay, so that's it. Now, again, okay, we all know about LED, so I'll just show you LED. There's one small thing we should know that LED has two legs, and the longer leg is called anode, and smaller leg is called cathode. Why is it so? Because in case if you are working with LED and you connected the longer leg with negative part of the battery or whatever connection you're giving, and means you gave the wrong connection, then it will get uh, short circuited, so it will not work. If it will work, then the brightness of the LED will be gone. So just remember that if in future I hope you might have taken LED, or you might have had interaction with LED anytime, anywhere in future. But from now onwards, you will not make mistake if you come across LED. Just remember, longer leg for LED. That means you have to always connect it with the plus sign. Smaller leg, cathode, connect with negative sign. And also, okay, you can connect it. We don't recommend to connect it directly because it gets burnt also. So we usually connect it with resistor. I already told you about that. That's it for LED. And now what I have. Okay. So yeah, I was going to explain. Sorry, I forgot. I was going to explain you about this multimeter. So multimeter is very easy but very complicated as well. If you haven't used, it will be complicated. But once you try it, it will be easy. And from today onwards, it will be easy for you, even you haven't used so till now. Just see and let's, let me invert. I want to. I don't think it's possible to read because it's upside down. Okay, I'll explain it like this only. So here you can see the symbol. V stands for voltage, A for ampere, and here is the symbol of ohm, which is the unit of resistance. Okay, and this is the symbol for diode, and this is a symbol for connectivity test, which I have shown like buzzer. So, and here you can see this is dotted as well as straight line, uh, which tells us that whenever we want to measure direct voltage, we have to rotate the knob toward this side only. Okay, and whenever we have to measure alternating voltage, then we have to rotate this side. Okay, and sorry. Okay, and now if you want to measure the current, you have to rotate it to the current side. And this that's the first thing. And second part is you have to just see the readings or numbers here, because it is very important. Like if you are going to measure, yeah, it's a little bit tough for you guys to read, but maybe it's tough for me. It will be simple for you. So here you can see if it's showing 50, yeah, to 20, 200, 600. So what I'm saying is that whenever you want to measure the voltage, and you know that the maximum voltage would be under 200, so you have to keep the voltage, this knob pointing toward 200. Okay, now For example, in our house, we get voltage around 240, right? 240, 260. So whenever we are going to measure that alternating voltage, we have to put it uh, toward this side because toward this side because it is showing alternating voltage here. Okay, this side, and it will be under 600, but above 200. Okay, and I don't have nearby socket. I would have shown you, but that's it for now. And there's one more thing for checking the connectivity. Like if you have a wire with you and you want to check either that wire is working or not, means either that wire is damaged or not, because you can't know if if you are connecting bulb and holder, but that bulb is not working, and you are sure that bulb is right. Your bulb is, I mean, in good, not good form, but it's working. But your wire is not working. So for that, you just have to take the wire. Okay, this plug in the red wire to the current side because we have to check the conductivity. And this black wire will always be in the middle. Okay, I'll show you this part also. Here we have three parts. Okay, one is for this one is for current. Whenever we will measure current here, then we'll plug red wire this side, and whenever we are going to measure voltage, we'll connect to the uh, sorry, yes, next, yeah, this side, voltage side. Okay, so for now, we are going to check the conductivity of this wire. Either this wire is working or not. So for doing that, we'll connect red wire to this side and white, black wire in ground. And then we'll rotate the knob to the speaker as I've shown you. So you can see that knob is at speaker. And if this wire is not working, and then we'll not hear any sound. But if it is working, then we'll hear a beep sound. Okay. Okay, get ready. Okay, I'll just okay. And by doing this, you don't have to worry about positive or negative because this wire is not connected to anywhere, okay, or any socket. So you just hold it like this. I'm having trouble. I will just keep the hair. I'll show. Just a minute, guys. Sorry, there was some issue. Now here I'll show you that how this works. I guess you can hear the beep sound, and I have just hold it like this. Since it's very loose, I can't show you. So connected one part to the red wire and another part to the black wire, and you can hear the sound. Okay, so that's it. And this is to test any wire. This is just a simple jumper wire, but you can test it with our aluminum, copper, or any wire. Okay. So here, this was the connection which I used to check the connectivity. I have pointed this knob on the speaker and connected the red wire to the this side milliampere volt ohm maximum 200 milliampere 250 fused. These are the threshold. Means you have to connect the red wire to the ampere current side to measure the current. Okay. So that's it for the multimeter. There are different kinds of multimeter. You can to hold the value. You can press this button to for the lightning, and you can do many other things by using multimeter. Okay, thank you. And now now I'll show you this Arduino. Uh, I don't have Raspberry Pi, which is also used in IoT projects, but this is also one of the major component. This is Arduino Atmega 25660, and here at one side we have digital pins. A stands for analog pins, and there are TX and RX for transmitting and receiving data. This blinking LED is blinking because I have used Arduino program, and I have set it for to blink it for 1 second and then get closed for 1 second. I'll show you the program right now only. Here's just a minute. Let me share the screen. Here you can see that in the program, I have delayed this blinking of LED for 1 second. So it's a very simple program. And I could have used all the other components and showed you the project, but that would have taken much time. Okay, so I'll just explain you. This is Arduino IDE, as we have our IDE for C, Python, and everything. This is for Arduino, and we use C language only in Arduino. Okay, here we are using void setup to set this LED built-in that output mode. Like since we can see the changes in LED, so it's an output, and then we are using this loop to repeat the blinking of LED. So, we are using digital write function, and then using LED built-in, and we are setting it to high. So for 1 second, it will be on. High means on, LED is turned on. And here delay is in milliseconds. So I have converted it. I have entered 1000 for 1 second, and digital write again to turn the LED off. That is LED position low for turning off, and delay for 1 second. I can change it. So you might have seen the programming of traffic lights. The basic concept of traffic lights are from here only. And I could have shown you, I didn't had all three color of LEDs, or else I could have shown you the programming of traffic lights. So what we do is we just select the pin numbers, and instead of writing LED built in, we will write the pin numbers, like at what output pin LED is connected, and for how many minutes or seconds we want to set it on, and then for how many minutes we want to seconds we want to turn it off. So this is the concept, basic concept and use of Arduino. And this is Arduino IDE. You can explore it on Google laterwards. Okay, so actually this was the third. I was supposed to show this in the last part, but since I was explaining you about Arduino, so I have shown you at the same time. So now you might be guessing what if we change the timing. So I'll try and show it to you right now only. I'll just change the timing for, okay, I'll do it for 0.5 seconds. Okay, so it will blink for 0.5 seconds, and it will be off for 0.5 seconds. I'll compiling. So compilation is done. You can see here, and then I'm uploading the video, this code. So uploading has been also done. So you can see that blinking of speed of blinking has is changed now. Okay. So this was simple explanation for Arduino and Arduino ID. Okay. Okay. Next, uh, I think it's enough for now. Yeah, just last thing. You might have heard about gates, logic gates, and gates, or gates. So this is the chip. Gates are like this only. This is the chip. I don't think you are able to see it. Okay. If you can see it, it's okay. If not, then also it's okay. Yeah, it looks like this only. Okay. Now I'll move ahead. I think I have explained almost all the things which I had with me. And now I'll move to the next part, which is PPT. Okay. Now here you can see Internet of Things. And Internet of Things, I'll just explain in the beginning of PPT so that I won't be reading line by line or whatever content is there in the PPT. So if you want to read it, you can pause the PPT and you can read it by yourself in your free time. Okay. So Internet of Things, uh, there are three terms in Internet of Things itself. Internet things and okay, two terms only. We can neglect of internet and things. Okay, two things. And but logically there are three things: internet, things, and electronics. So anything we can see nearby or any physical things which are present, we can embed that things with electronic components. And by electronic components, I mean basically sensors and actuators or other things. So anything if that got embedded with electronics, and along with that, it got connected with internet. Okay. So internet is important, because then only we can do all the work. So once that thing is done, that thing along with embedded electronic component that gathers data, collects data, that sends the data to the internet or cloud, and there we are going to become a data engineer or data scientist, right? So our job will be to use that data and convert that data into information, and that information will again be used to to drive business goals, like whatever in whatever company we are working. Like if we are in medical field, then all the sensors and things which are in hospitals or all the components, even in human beings also, like we use smart watches, or even there are sensors which monitors our heart rate, pulse rate, BP, everything. So those data will be used by doctors, and it will be our job to convert that data into information and send that information to the doctors, and they'll take out the conclusion from that, and it will become easier for them to operate. Similarly, if someone is in different field, it could be anything: sports, hotel management, any manufacturing. So there are ample amount of opportunities, and as well as there are so many actually IoT is in that keyword itself has been started from 1990, has been inducted, I'll say. I mean, the word Internet of Thing is around with us from last 20 to 25 years or 30 years to 3 decades. But the extent of use has been increased nowadays. Per person devices has been increased nowadays, and it will be increasing in future also. Okay. So now I'll start the PPT, and I'll just show, explain few keywords if it will be there, or else I'll just move. Okay. Uh, Here, what is IoT? As I have explained, electronics, software, sensors, and internet connectivity, all these things, collectively makes Internet of Things. Built-in sensors, variables, history. This IoT term got termed in 1999. Yeah, 25 years or 20 years around. It was first termed by Kevin Ashton. What does he say? You can read it here. Okay, so there are some rumors also, like some people say you can do this, but uh, it's not all true. Okay, now the internet life cycle, that things which are embedded with electronics collect the data, then that data is been transferred to cloud, and there it we analyze it, and then we take decision based on that. Yeah, collection by sensors, and it is in smart home. Data has been collected from our home. In cars, we have multiple sensors. In offices, we have other sensors also. So in manufacturing plant, they have sensors everywhere. Even the trucks which carry the uh, that whatever products the company is manufacturing, those trucks are also enabled with uh, sensors and GPS, so that one can track that uh, truck and other vehicles. Analysis, action. Yeah, here I would like to explain one important thing. Send a notification. So you might have heard or might have seen in movies also that if some crimes takes place nearby, and that information, if that person or that uh, government or non-government organization is using IoT, then by default that information will be sent to the police station. Okay, so that is a use of Internet of Things. Now, how IoT works, structure of IoT, tagging things, feeling things by sensor, shrinking things, miniaturization also. Uh, it's we all know that Elon Musk is working on nanotechnology to implement it in our implant it in our brain, and then uh, we can become cyborg, or we can cure some illness which isn't curable. Okay, now these are few applications. You name it and you'll have it in IoT, and that's true. This is another example of waste management by using Internet of Things in smart cities. Smart cities is again a collection of, like, there are too many sensors and smart lighting. You can see I have shown you that in starting I have shown you one sensor, LDR, light dependent resistor, that works in smart lighting, like that detects the intensity of light in daytime and in nighttime. So once the intensity of light decreases, so resistance will increase, so that will turn on the light. So that's why I showed you those components. And here also, here weight sensor, I have shown you weight sensor. If not, I'll show you again. I can point. um, um, Here you can see this is a weight sensor, and these are the things, this is the one thing which is which is embedded inside the dustbin. So if we are having, like, we have two different dustbin, one is for wet garbage and another is for dry garbage. So for wet one, once the dustbin will be filled, that will have some specific or weight. So this weight sensor will have some threshold, and once that threshold will be crossed, it will send the data to the server through Wi-Fi that this dustbin has been filled, and they will send the truck, and that garbage truck will pick the garbage. So this is again a very small component which can play a very big role in smart cities. Okay. Next. So in cows also, they have embedded not only non-living things but living things also, that are now part of Internet of Things. And a single cow generates around 200 MB of information per year. Okay, and this is another example of shopping without using wallet, or you don't need to stand at a queue because that product will contain the barcode or QR code barcode only, or some kind of tag, maybe RFID card also. I think that won't be used. Okay. And as I explained that we can monitor, we use smartwatches, we have heartbeat monitor, VP monitor, so we can track each and everything about ourselves. So IoT is helping us for doing that. And this is current status and future prospect for IoT. You can say that day by day our population is also increasing, and uses of devices per person is also increasing. So in coming future, we are going to have a lot of data. So all the DVDA guys can cheers that will have a great opportunity in future, because anyway, data are not going to be anywhere. We just have to have a skill so that we can get ahead, and we can work efficiently. Here, since I have taken this pic from a website, I didn't saw that it has a prediction till 2020, which is now past, and I believe we have around this much of devices, connected devices today. If not, just let's just Google it. Okay, you Google it and let me know. Now, big data is not magic. It doesn't matter how much data you have if you can't make sense of it. It's truly said. Now we are getting mm, into data science, so we should note that it's no use of data if we can't convert it into information, and that information is also waste if that is not helping a company to grow. Okay, here is again a small video of examples of IoT. Okay. So that's it from PPT. And now I'll show you one or two more projects. Um, Thank you from PPT side. And now I'll show you, yes, here. Um, I have connected LM35, that is temperature sensor, which measures room temperature. So this has been on since 4 a.m. and now you can see the data. So I have plugged in at around, okay, 5 a.m. 3:30 a.m. or something. So you can see at midnight what temperature was, and again uh, it got fluctuated. Okay, and this is just a dummy example. I mean, it's not 100% accurate, I'll say, but this is just a way that I have used. And since I have shown you this circuit in the starting also, a simple circuit, this is LM35 temperature sensor, which is currently working. You can see here, it's live data. Yeah, it's live. It's working 7 a.m. It was on at 6 a.m. also. And, okay, and I'll show you two more projects, small projects by using cloud. And here I have used Bolt Cloud, and here the status of my that device is on. It's showing online. I have kept product name LM35. Okay, now just wait for a second. I'll show you the. I'll just do the setup, and I'll directly show you another one or two examples. That's it. So here I have done the setup, and I'm going to turn on and turn off this LED from the cloud. Okay. Now I'll share this screen. As you can see that here I have done the setup. Now the product is LED control, and you know, I've just written the code. I'll show you the code here. Okay, first see that it's getting by clicking on, it's turned on, and if I'm clicking on off, it's getting turned off, on and off. Also, you can notice there are two colors on this board. One is green and one is blue. That green color indicates that my device is connected to the cloud, and blue color indicates that device is receiving the power. In any case, if that green color gets turned off, that shows us that our connection has been lost. Okay. So again, turned on, turned off. That's it. Now I'll show you the code also. And here in the previous one, now since I have disconnected the resistor, sorry, temperature LM35, that's why it is showing error on the screen. You can see there's one more feature here. You can like it's just a small database from both, but in other also we can do. We can select the date, and we can select start date and end date to select the data. We can filter it. Also, we can select the timing. For example, if I want to select the data from 6 a.m. for till now, then it will give us for from 6 a.m. to 7 a.m. to 7 a.m. Okay, okay, actually, sorry. Since I have remote, that's why it's not working. I have to reconnect it and then it will work. But now I'll show you the connect coding. That's important part. Okay. Here you can see a small program uh, I have written for turning on and off LED from cloud. And before, when I have shown you that uh, Arduino, and they also I turned on and turned on the LED, but that was from my local desktop. But now I can turn on and off this LED from a server. It means I can do it from anywhere. So this is a example of Internet of Things. And let me check if anything else is there. Yeah, for this temperature, I'll show you the code for temperature sensor also. Here I have module. Um, okay, this product is not linked now, so I won't be able to show. Okay, no problem. I had other two also, buzzer and LDR, but since I have already taken so much time, so I won't go ahead now. That's it from Data Moguls, Team 5 from DVDA. And have a nice day, everyone. And have a nice weekend also. So I would like to conclude my presentation over here. And I believe that you might have gained some information today, and not only information, uh, you can implement whatever practical information I have shown you. Also, there's one small bit of information I want to uh, just share with you guys. Just, okay, so here I'm just showing you the socket. So you can pause the video for a second, and you can answer my question to yourself only, not to me. That why this hole is little bit bigger than these two. Okay. So if you know the answer, it's good. But for those who don't know, I'll just tell you the answer. I have the board. Okay. So answer is very simple. We know the formula of resistance. Okay. Formula of resistance is rho L upon A. Rho is constant term. L is length of wire and divided by area. So that we all know that that is for earthing purpose. Like we know that when current gets exceeded through this, it goes to earth. Okay, because earth has a zero potential. So what happens is uh, by increasing the area, uh, we implemented the formula, like we use the formula for resistivity. Yeah, resistance is equal to rho L upon A. Resistance. You can see here, resistance is equal to rho L upon A. This is the constant term. L is for length, A is for area. So by increasing area, what happens is resistance get decreases inversely proportional. So whenever if something wrong happens, or something like if any wire is touching to the product or current is increasing, so current will always follow the path where resistance is less. So since the resistance is less in the upper part, current will flow to that side first. So that is the reason, and I wanted to tell you that if you know that, then it's good. But for some of you who didn't know, you'll think that you have learned one thing today, and it made your day. So that's it. There is I don't want to. There is nothing else. Okay, I have had already taken too much time. So thank you guys if you have watched till here. I'm sure you might have played it at 2x or 1.5, but it's okay since you have watched till here. No problem with that. And if you find any error or any mistake, you can direct message me on WhatsApp, or you can email me. I'll share my LinkedIn link also. You can connect me with there. You can send me the invitation. I'll just connect you with you guys. Okay. And also, I would love to connect with all of you so that in future we can use IoT as well as data science, and we can build something new and innovative products for our country and for the world and for the people and human beings as well. So thank you. That's it from myself. Again, I'm Prabal Pandey. Hope to meet you soon. All the all the best for future ahead. Thank you. Have a good day.